important? Yes. Basic hematology, then immunohematology. It is also called as immunohematology is also called as transfusion medicine, then bleeding disorders. Bleeding disorders. So before discussing about branches of hematology, you must know the functions of blood. I know again boring things, but we need to know basics. So tell me any 20 functions of blood. I need 20 points. Yes. Regulation of body temperature. Okay. Body temperature, then exchange of gases. Okay. O2 and CO2. Then very good. Acid-base balance. That is called buffer action of the blood. Very good. Then transport of nutrients. Okay. Transport of nutrients. So then what are the other functions of blood? Very good. Infectious protection. Protective role of blood. Why? How blood will protect us? Because it has WBCs and WBCs will fight against infections. Very good. Then very good. Clotting activity, clotting function, very very important function, right? So clotting function mediated by platelets. Very good. Very good. Then other functions of blood. I think 20 points. Until that I won't give you. Yes. Clotting function, very good. Can anyone say other name of clotting mechanism? Coagulation. Okay, clotting coagulation. But do you know what is hemostasis? Arrest of bleeding. It's a part of hemostasis. Any other things about blood functions? Yes. I need something I will not tell you about. Yes. Yes. Hormones. Osmosis. Any more precise? Okay. Excretory function. Metabolic waste products will be, transporting nutrients and excretion. Okay, excretory function. Then listen. Do you know what are hormones?
Yes, sir.
There are two types of study of hormones is called as yes, endocrinology, right? Endocrinology, right? So there are two types of endocrine glands. Can you tell me what are those? Exocrine and endocrine. What is the difference between those two? What is exocrine? What is endocrine? Yes.
Endocrine will direct the blood stream.
Endocrine or someone saying direct. That means they will release hormones into blood vessels, right? So into blood. So that will transport to organs. Then exocrine means
The ducts will run.
through ducts. There will be some dedicated ducts and it will. Example. Can you give example of exocrine? Salivary glands. Pancreas. Right? Pancreas has both endocrine and exocrine. Anyway. So endocrine is directly they will release. Example of endocrine? Pituitary or thyroid. Okay. Even for pituitary there is something called hypothalamic trap. That I will discuss later. So endocrine function is one of the functions of blood, right? All blood-mediated hormones will be transported via blood. Any more other functions? Any interesting functions of blood? Apart from this. Right. Yes, students? Any other extraordinary point you want to add to it? Say again. Yes? You don't have any points. Anyone? Huh? Hemolysis. How can that be a function? It's a pathological condition. Hemolysis. Maybe can you justify it? Okay. Hemopoiesis you say. Not hemolysis. Hemopoiesis, right? Alright, very good. Hemopoiesis, that is one function we can have. It's a very broad statement. What is the meaning of hemopoiesis, by the way? Formation of blood cells. So where do they form? Where blood cells will form?
Red bone marrow, longest bone in the body.
Huh?
The
Bone marrow. Alright. Actually there are three stages for preparation of blood during the gestational period. First 3 months, next 3 and last 3 months. Right? Can you tell me all these 3 trimesters? During first trimester, where the blood will be produced? Okay, by the yolk sac of the embryo. And in the second trimester, liver will produce the blood. And during third trimester, the bones will start producing blood. Right? Okay. Fine. So tell me the properties of blood. That can be a part of our points. What are the properties of blood? How properties are different from functions? Yeah. Properties of blood. Yes. So when I say properties, there will be some basic things. Color. What is the color of blood? Pink. Red. Very good. Why blood is in red? Because of presence of hemoglobin. Why hemoglobin is in red? That is my next question. Why it is red? Why not brown, black or any other colors? Yellow? Carries oxygen? Iron. So? Yes. Any idea? Heme pigment. Any more idea? Any more answer? Think logically. I think I discussed with you, right? One time. No? Okay. How many of you know iron? Everyone knows, right? What happens to iron when we expose? Imagine an iron ring, okay, piece of iron, and we kept on the environment on this table for next 6 months. What happens to the iron? It will rust. Iron will rust, right? What is the mechanism of rusting? Yes, oxidation. Oxygen binded with iron, right? So Fe2 plus. Now, a rusty material, what is the color of rusty material? Reddish brown, right? Brownish red, right? So the same phenomenon going with the blood actually. So hemoglobin has a protein, it has a porphyrin ring, and it has iron molecules. And these iron molecules are constantly oxidizing. That means literally blood was rusting every second. So maybe we are blaming iron things, but rusting is one of the important properties for staying alive. See, blood was constantly rusting and we need it. See, interesting, right? And that's why blood is in red color, just like iron. Yeah. I think I can confidently say that we are studying about bloody things, right? Yeah, this is blood. Yes. So these are some parts of bloody things. Then what are the other properties of blood? Shape of, why you are confused? Okay, when I said blood, why are you worrying about RBC? I didn't discuss about RBC properties, right? Blood doesn't mean RBC, right? Yeah, keep in mind. I think now I need to stay here. Okay, tell me components of blood. I said components, okay. Or composition. Composition is not right word, okay. Components of blood will be cellular and fluid. Fluid component will be plasma. Plasma have composition. Okay. Then cells, what are the types of cells we have in the blood? RBC, WBC, and types of WBC, granulocytes and agranulocytes. Types of granulocytes, neutrophils, eosinophils and basophils. Agranulocytes, lymphocytes What is other property? Only one answer. Yes. Liquid in nature. Okay, so I need to give one point here. Viscosity. You are trying to say viscosity. That is one of the baddest term. We should not use viscosity. But when we are saying viscosity, what do you think about that? What? It is slightly thicker than a liquid. What is the mean? What do you mean by liquid? There are many liquids. What do you mean by liquid? Is it water? Is it a fevicol? Is it a oil? Fluid. What do you mean by fluid? Listen. Compared to water, slightly viscous. Right? Compared to water, that is slightly viscous. But we should not say this is a semi-viscous fluid. That is wrong term. Okay? Let never be a viscous. If any fluid is viscous state, that is a pathological condition. The patient will die. Okay. Only one exception is there, that is synovial fluid. Synovial fluid is slightly viscous. Apart from synovial, no other fluids in human body are viscous in nature. Okay, keep in mind. So, yeah, compared to water, slightly viscous, but always keep in mind, compared to water is important. Compared to water, it is slightly viscous. Next, other property of blood. Yes, I don't know why the hell it's not, detecting. I think I'll keep here. Yes, is it? Yeah, pH. What is the pH of the blood? 7.32 to 7.42. Some textbooks say 7.35 to 7.45. So this is the universally constant pH of the blood. Listen, if blood pH is greater than this value, that is called as now I got you. Greater than 7.42 is called as base. Yes, there is a proper term for it. Okay, alright. Alkalosis. Okay, cis. All blood related things will end with cis. Okay, the pathological condition of blood. So alkalosis means increased this one basic nature, and less than 7.32 will be acidosis. Now I want to tell you one important thing. If blood pH is less than 7.3, the patient will immediately they will die. If it is greater than 7.45, that's it. They will die. So blood has a very narrow range of pH. If you alter the pH, that's it. The patient will die. Why this connection is there? Why blood pH plays a crucial role? Any idea? Why having, I want to say one more thing. All mammals have same pH range. All mammals, all eukaryotes. I need to say mammals. Okay. Why we are struggling with this range of pH? Any guesses? Why, if this range alters, we are dying? Listen, constantly, maybe if you are eating some acidic things, maybe lemon juice, definitely your blood pH will become more acidic. Maybe it will go up to 7.32. But there is a buffer mechanism to bring back to this level. Even if your pH is less than 32, that indicates your buffer mechanism has been collapsed. Why your buffer mechanism collapsed? Maybe you are having a huge acidic condition. We don't know what is the reason. We need to identify that. But why this? Why this triggering a death to the patient? Why acidic or basic condition leading to a death? Any guesses? Any mechanism? Any ideas? Do you remember what are enzymes? What are the factors affecting enzymes? Temperature, pH. Every enzyme has its own particular pH for its activity. Do you remember? All gastrointestinal enzymes need pH of 7 or 2. Acidic environment for the activity of halted, game over. All these enzymes will be collapsed. All enzymes won't work. And imagine the enzymes that are not working in your eyes, brain or heart. Entire organs will be collapsed just because of altering in the pH. So pH plays a vital role. Maintaining pH is one of the important things to measure in the ongoing patient. Okay. Yes. That's it. That is about the pH. Any other properties of blood? Volume. What is the normal volume of blood? Yes. Yes. 5 to that depends on body weight. 6 liters in an adult. Okay. That depends on body weight also, but usually that will be 5 to 6 liters of blood will present in a healthy adult. That is the volume of the blood. Any other properties? Color, viscosity, appearance. What is the appearance of blood? Can you tell me the difference between appearance and viscosity? What do I mean by appearance? Very good. Viscosity is something relevant to texture, and appearance means? Appearance means, in a nutshell, we can say it's an opacity, the transparency of the blood. So, what type of liquid is blood? Is it transparent, clear, turbid? Any other? It's turbid, right? You can't see through via blood, right? It's just like this glass. You can't see through via blood. So it is turbid in nature. Okay. But we need to be cautious when we are using turbid. Okay. This we are using in a chemistry. Yeah. Why I discuss this? Because I need to discuss the branches of dermatology. For that I need this round knowledge to you. So coming to, I need to discuss one more thing, that is anemia. Then I will go there. What do you mean by anemia? Please write down these points, okay? They will be encountered. You will encounter these points again and again, and there will be a viva. A direct viva will be there, and these marks will be directly entered into your experiment 1 marks. Okay, so be cautious. Take notes. First of all, I really appreciate it. Everyone is a PT. I thought you were really lazy students, but you are not so bad. I had a bad impression on you. Very well done. You can clap yourself. Very good. I was so bad. You bad students. Because that's what I felt. Since last time I don't have classes to you. Anyway, yes. What is anemia? What is the concept of anemia? Tell me, students. Yes, Priya, I think one of the good students. Sit, friend. I can't hear you. That's right. You sit beside Jariel or Hita. Yes, sit there. Yes, come. What is anemia? RBCs?
Yes.
So you are trying to say reduced RBCs is anemia, right?
Yes.
Are you sure?
Yes.
Okay, and someone saying reduced hemoglobin is anemia. Then, what about reduced volume of blood? Is that anemia? Reduced volume. So, yes, I am really happy that you understood the concept. Just reduced RBC doesn't mean anemia, or reduced volume doesn't mean anemia. It's a collective terms, right? But keep in mind, anemia always focuses on RBC count compared to other parameters of the blood. Okay, if RBC count reduced, definitely it will shoot anemia. Okay, RBC plays a vital role to understand the severity of the anemia. Okay, say for example, a patient has a severe hemorrhage. A patient met with an accident and he lost 1 liter of blood. Okay, immediately we took him to the hospital and we have given a saline, okay, to increase the blood volume. Got it? So now the volume looks normal, That doesn't mean patient has a non-anemic condition. We need to cross-check with the RBCs of the blood. So that's why immediately we will go for blood transfusion. If we give blood transfusion, we can outshoot his anemia condition. So now you know the concept of anemia also. We will go deeper in the later stage of this process. Now you understood the concept of anemia, right? Now you know what is anemia, what are the components of blood, what are the composition of plasma, and can you tell the difference between plasma and serum?
The plasma without anticoagulant.
Plasma means blood plus anticoagulant will be a plasma. Centrifuge, upper portion will be plasma, and blood, let it clot, then centrifuge, then the supernatant will be serum. Clotted blood will give serum, unclotted blood will give plasma. In natural condition, we will have plasma or serum in our body. Yes, in the normal body we have plasma or serum. Plasma, right? Someone tried to say serum there. Okay, no. What is the natural anticoagulant? Heparin. What is the classification of anticoagulants? We have two types of anticoagulants. What are those? No. Before artificial and natural, there is one more classification. Okay, natural, artificial. Now, what are the types of artificial? Now, in vivo, someone said in vivo and in vitro. What is the meaning of in vivo and in vitro? What is the meaning of in vivo? Something that we can give, we can ingest, right? So in vivo, example of in vivo, oral anticoagulants. These are called as oral anticoagulants. Can you give one example of oral anticoagulant? Any idea? I think you might not have idea. One example will be warfarin. Have you heard about warfarin? There are no warfarins, they are warfarin, okay? It's an oral anticoagulant. It looks like an EBPA powder, but it's a tablet or powder. It's an anticoagulant that can be given safely to the patient. So it can be ingested, okay? And artificial anticoagulants, okay, in vitro anticoagulants. What is the purpose of in vitro anticoagulants? Purpose of in vitro anticoagulants. Now you are falling under bad students category. You must answer. Yes. Yes, Mr. Tapalo. What is the meaning of in vitro anticoagulants? Yes. Okay, something that are used outside the body are called as in vitro anticoagulants. That means they are not meant for ingesting. Examples of in vitro? Very good. We are all lab anticoagulants we are using in blood vials are in vitro anticoagulants. Very good. So there are some more anticoagulants used in blood bank here. Blood bank we are using in vivo anticoagulants again to preserve blood. So can you tell me anticoagulants used in blood bank? Anticoagulants used in blood bank. Yes? You don't know? I think you might don't know right now. ACD, acid citrate dextrose, CPD, citrate phosphate dextrose. ACD and CPD are some of the common anticoagulants used in the blood bank or blood bank. Okay? ACD and CPD. Acid citrate dextrose, citrate phosphate dextrose. Okay. ACD with the K is there. That we will see later. There are some advanced anticoagulants.
Second one is
CPD, citrate phosphate dextrose anticoagulants. There is one more SHM, SAGM, that we'll discuss later. Okay. SAGM stands for sugars, adenosine. There are some amino acids here I forgot. I will discuss later. Okay. You just keep in mind SAGM is used in blood bank. I didn't prepare up to this level. Okay. Next. So now you know the concept concept of anticoagulants also. So what type of no. If I say EDTA, what type of anticoagulant is it? Tell me through classification. What type of anticoagulant is EDTA? It's an in vitro, artificial in vitro anticoagulant used for lab diagnosis. Okay. Very good. Then what is warfarin? Warfarin. Warfarin is an in vivo oral anticoagulant used for therapies. Therapy to the patients, right? Therapy to the patients. Very good. What is a natural anticoagulant, by the way? Heparin. I think I want to tell one interesting thing about heparin. You just imagine, students. Imagine there is a, this water tin, 20 liters water tin, mineral water tin, right? Okay, imagine there is 20 liters of blood in a bucket. And can you guess how much, what quantity of heparin we need to take to keep 20 liters of blood in liquid state? Maybe half liter of heparin, 1 liter of heparin for 20 liters. Can you guess the proportions of heparin to 20 liters of blood? Maybe we need half liter of heparin to keep 20 liters of blood in liquid state. Any guesses?
20 liters.
Huh?
20 liters.
So we need 20 liters of heparin for 20 liters of blood. That is a Simran statement. Any other guesses? Yes, Mr. Non-GLP, non-TPA and non-buttons to the lab coat. What is his name, by the way? I forgot. I know his name. Pradeep. Very good, Pradeep. Now you are under my scan. Next time you must have a headmaster spoken, Pradeep. Yes, any guesses? Proportion of heparin to blood. Yes? 100 ml. Yeah, she came close. Literally for 5 liters of blood, we need 1 ml of heparin. That's enough. Just 1 ml is sufficient to keep 5 liters of blood in liquid state. That means you can understand the efficiency of heparin, how strong it is. Heparin is one of the strongest chemical, okay? You just imagine. Heparin is very costly also to use as an anticoagulant in the lab. It's a natural anticoagulant. Very, very strong, very potent. Alright. So that is about heparin. That means just we need 4 drops of heparin in 20 liters of this one, blood. So heparin is very strong. That I will discuss later. Heparin therapy. Even heparin toxicity can happen. Imagine you given 2 drops of heparin to the patient. That's it. It will become over thin. That means blood will become like water and patient will die. So you need to be very cautious when we are keeping the patient on anticoagulant therapies. Very, very sensitive matters. So that is about heparin. Now I will tell the opposite to heparin. If you want to kill someone, you find ways to clot the blood of the patient. Okay, don't do it. But if you clot the blood, that's it, they will die. And this is one of the important strategy for nature also, or survival in the wild. So there are a group of creatures. They have evolved and they have understood that in order to save them, in order to protect them, they need to kill their predators, right? To save or killing them. So they evolved chemicals. These chemicals will, clot the blood of the patient, the attacker, the predator. So those are called as poisons, venoms. So now we understood what is the concept of venom. Venom will block the heparin activity. Try to find the ways to block the heparin receptors on the blood. So let the blood clot and they will die. And that's how the snake bite leads to death. Okay. Snake venom will clot the blood. Now the people will die. So how snake bite will leads to death? So snake bite clotting of blood. Now the blood present in the lungs also get clotted. Lungs has something called surfactant. There are two layers of lung. Do you remember? Peripleural space. So visceral layer and pleural layer. So there are visceral is outside and pleural is inside. In between these two spaces there is a space called peripleural space. In this space there is something called a liquid that is called pleural fluid. And this fluid has a chemical called surfactant. This surfactant will minimize the friction between these two layers because the lungs are constantly expanding and contracting. So there is a constant friction. What I was trying to say is, once the blood is clotted, the exchange of fluids will be blocked because the liquid state of the blood has been diminished. Now this surfactant will become froth. Froth means surfactant froth.
Yes.
Same froth will be generated in the peripleural space. Now this froth will start coughing out by the patient who had a snake bite. Because snake bite caused blood clot caused reduction of friction, lead to froth formation. Froth will be expelled out from the mouth. See, now there is a huge connection. That's why a snake bite leads to froth, coughing out of froth. The blame thing can be done to antagonistic of heparin. Yeah, now you know that venoms also. And there is another way of killing patients. Yeah, one is clotting the blood. Second one. This happened to me, not to me, to my batchmate in masters in second semester. What happened? We are doing phlebotomy. The problem with my masters is they did BSc in Zoology. There is a eligibility criteria. Any life sciences can do MCQs. So non-MLTMs came up to masters. So they started playing games with veins. Then what happened? One of my classmates, she collapsed after blood collection. One person took blood collection, okay? He took blood and she collapsed. And he don't know how to collect blood. And we came to know that it went up to the coma state of her. There is a minor clot in her meninges and they removed and she recovered after 1 month, okay? A minor surgery has been done. And you know what happened? Mistakenly he introduced a small air bubble into the blood vessel. Air bubble called as embolism. This air bubble entered into the blood vessel. The problem is this platelets has a property. If a platelet get in contact with air, platelet will start clotting the blood. That's how hemostasis works. Once you connect her in contact with air, that is called contact inhibition of platelet. It will be activated and it started clotting. And that clotting happened inside the vessel since they introduced a air bubble. Okay, so this is one warning to you. If you don't know how to collect blood, don't touch the fellow student, okay, fellow classmate. So don't introduce any blood vessel at any air bubble into the blood vessel, okay. That's why always nurses will tap the syringe. Have you seen? They will remove the gap and they will tap it to see any possible air bubbles in the needle of the syringe. So need to be very cautious regarding air bubbles. Many fundamentals, right? Now coming here to basic hematology. So now tell me the normal TRBC count. What is the normal RBC count? 5.5 to 6.5. 6 to 6.5. What? Million cells per cubic millimeter of blood. Very good. Then what is the TWBC count? Yes, 4,000 to 11,000 cells per cubic millimeter of blood. What is the normal platelet count? 1.5 to 4 lakhs cells per milliliter of blood. Keep in mind, this value is very important. Never do mistakes in that aspect.
How many of you have chosen the GP course? Remaining who have not chosen the GP course and choose your GP course till midnight today.
Sir, many of them are facing errors. They are trying.
CUIAHS बैठा हुआ है yes CUIAHS is not working properly. Once it will start working, you choose your GP course. There are those who want to complete their GP course without any credit. They are requested to choose their GP course on LinkedIn. That will be easy for you. I have nothing to do with that. If you are going to choose under DSW, then you have to be offline. Then you have to attend classes. Right? That even requires attendance. Under DSW, it requires attendance. When under LinkedIn or UNESCO you are part, you can even do your course in one day. Just choose your course today and finish it tomorrow.
So choose GP, okay? Don't neglect it. All right. Stay focused. You're paying 70,000 per semester, right? Across average, 50,000 average. So you have to listen. Don't waste your money. Yes. Next. Where am I? Platelet count. Done. What is the normal HB count? Normal HB count. Yes. 11. Okay. 11.5. Actually, that is 12 now. 11 to 16. What? Kgs. Grams. Milligrams. What do you think? Is it mg, g, kg? Yeah. Who said kg? No. I know you, Pradeep. Pradeep, right? Very good. Yes. Any guesses? It is grams. Always keep in mind. Okay. Hemoglobin is always in grams. Hemoglobin is in grams. Okay. Not milligrams. Not other things. Of course, not kgs, right? Grams. So grams per what? Very good. Grams per deciliter. Okay. Grams per deciliter. Okay. Next lab test that we will perform under hematology. What is the name of immature RBC? Immature RBC is called as what? Yes? You already studied chemopoiesis to my knowledge. So what is the last stage of for chemopoiesis? Mature red cell, but before that? Last cells will become mature RBC. What are the 6 cells we have? Early normoblast, intermediate normoblast, late normoblast, then proerythroblast, reticulocyte, then mature RBC. Reticulocyte is called as immature RBC. Reticulocyte. Write down the normal reticulocyte count. 4 to 6%. 4 to 6% is reticulocyte count. Okay. Sometimes they are saying around 2 to 3% also. So maybe you can write like this. 2 to 6%. Textbook to textbook, the reference values will change. Okay. 2 to 6%. Immature RBC is called as reticulocyte. This is one test in basic hematology. Okay. Next test. These are some interesting tests. You know this one also. DLC. What is the meaning of DLC? Differential leukocyte count. What is the normal count of DLC? What is the mnemonic I discussed with you? You remember? What are the most abundant cells of WBCs in DLC? Yes, it's Javier. What is, tell me the sequence of cells. Never let monkey eat banana. Now tell me. Neutrophils, normal value 60, around 60%. Then lymphocytes 20 to 40. Monocytes, okay, 6 to 8 percentage. Eosinophils, 1 to 4%, and maybe 2 to 4% of 1 to 4. And basophils, 0 to 1 percentage. The least populated cells are basophils. What are the smallest blood cells? Smallest blood cells. What are the smallest blood cells? Any idea? What are the smallest blood cells? Okay, I think I need to tell you this one also. Imagine, last time I discussed with you, right? This dot will have how many red blood cells? 5. Assuming this is cubic millimeter of blood, it has 5 millions of red blood cells. Compared to this, in the same dot, how many white blood cells are present? In the same dot, how many white blood cells are present? 4,000. In the same dot, how many platelets are present? 4 lakhs. Maximum 4 lakhs. Do you remember? Now listen. This is RBC. This will be the size of platelet, and the size of WBC will be the size of this building. Comparing to this scale, that is the scale of WBCs, right? WBC is very big. WBC, platelet, and platelet will be size of this room. Okay, this is RBC. Yeah. So what is the smallest white blood cell? Smallest white blood cell. Yes. Any guesses? You know, interestingly, that is platelet. How platelet is a white blood cell component when I am discussing size? Any idea? From where platelet was derived? Platelet was derived from what cell? Megakaryocyte. Megakaryocytes are a subsets of what? White blood cell. What white blood cell? Keep in mind, one of the subset of monocyte is megakaryocyte. And megakaryocyte will give platelets. And another subset of monocyte is macrophage. Okay, macrophage is a subset of monocyte. Anyway. So the smallest white blood cells, smallest blood cells are RBCs followed by platelets. Okay. Then the least populated white blood cells are basophils, and the most abundant white blood cells are neutrophils. What is the function of neutrophils? Function of neutrophils. Okay. Imagine. No matter whatever pathogen entered into the blood, okay, it can be a bacteria, it can be a virus, it can be a fungus, it can be a parasite, it can be even a prions. You know what are prions? Infectious proteins. Anyway, whatever entering into the blood, the first white blood cell that will try to attack them will be a neutrophil. Neutrophils are the first line of defense cells. Whatever pathogen entering into the blood, first neutrophil will attack them. Clear? So they are called as first line of defense. First line of defense. Okay. Now, if a parasite, can you give example of a parasite? By the way, example of parasite. Tapeworm. Tapeworm is a intestinal parasite. Any blood parasite? Huh? What? Leech. Leech is not it's not a medically important parasite. That's another category. No, not leech. What is your Srishti correct? Leech is not answer. Yes, any idea? Any one blood parasite? I will give one clue. It is a celebrity status. It's a celebrity parasite. How many? I think mosquito. Now tell me the parasite. Malaria parasite, very good. Yes. What is the parasite name? Parasite that causing malaria. Oh, falciparum, okay. Falciparum, okay. Malaria falciparum, okay. Yes, oval, falciparum, then malaria, and there is one more. Plasmodium falciparum, Plasmodium oval, Plasmodium vivax. Anyway, listen. If a parasite came into the body, there is one type of white blood cell that will attack the parasites specifically. That white blood cell is eosinophils. Eosinophils will fight against parasites. Keep in mind. Eosinophils will fight against parasites. Clear? Write down these points, okay, everyone. Eosinophils will fight against parasites. Then there is one more interesting thing. Eosinophils are granulated cells. Imagine eosinophils has a granules. These granules has histamine chemicals. Histamines will cause vasodilation. What is the meaning of vasodilation? Blood vessel will broaden, right? It will enlarge. So enlarged or vasodilation lead to more fluid infiltration. Okay? More fluid will be infiltrated. Now there is a problem with this mechanism. These eosinophils will bind with one particular immunoglobulin, that is IgE. Now what is immunoglobulin means in area? Antibodies. There are 5 classes of antibodies. Tell me the 5 classes of antibodies. What is the primary purpose of antibodies? To fight against infections. So I used to say that it's a game of destruction, right? So these are the 5 classes of antibodies: IgA, IgG, A, M, E, and D. So IgE antibodies will bind to the eosinophil. Now eosinophils will release histamines. Histamines will cause vasodilation. Vasodilation will lead to more fluid infiltration, leads to swelling. Simply, that is how you will get a swelling. The mechanism is this. Okay, one of the mechanism is this. Now the problem was, imagine this parasite present in the lungs, and now eosinophils in the lungs has activated. They released histamines. Blood vessels in the lungs has been vasodilated. Now there is a fluid retention in the lungs, leading to emphysema. If there is a fluid in the lungs, what happens? You can't breathe. That leads to patient death also, due to hypoxia. Okay, lung emphysema. Now, before death, the patient will start having hyperventilation. A prolonged hyperventilation is called as asthma. Right? So now there is a link between asthma, eosinophils, and parasites. See how they are interconnected? So, yeah. You just remember that is a function of eosinophils, okay? They will cause asthma, they will cause allergic reactions, okay? Allergic, nothing but histamines. Histamines will cause, localized itching. Okay, these two are allergic reactions. So this is a function of eosinophils. Then coming to the basophils. Whenever a virus entered into the blood circulation, a basophil will attack the virus. That is the function of the basophil. Basophils will attack the virus. And also, if there is any unfortunate tumors, cancer cells, basophils will attack the cancer cells. Basophils are anti-cancer, antiviral. Then, yes, Mr. Tablo. What? Function of eosinophil. In a nutshell, eosinophil will mediate anti-parasitic action, and it will by eosinophils. Parasites are killed by eosinophils. That's it. Parasites and allergy parasites will be killed by eosinophils and allergies are mediated by eosinophils. Or simply, if there is a parasitic infection, when you count DLC, eosinophil count will be increased greater than 4%. If eosinophil count is more than 4%, that is an indication of possible parasitic infection in the body. Now understood that? How Pradeep was very busy. He wanted to do research right now. He was trying to search in mobile. Am I correct? You used mobile there. You don't have mobile. Then stay at the board, okay? Why you are still in body force? Why you are not keeping buttons to the laptops? Anyway, where am I? Parasites now. Basophils actually. Anti-cancer and antiviral. Now I want to say one important point, that's why I connected all these things. Basophils will secrete one important chemical. Can anyone guess what is that? Huh? Very interesting. Heparin is secreted by basophils. Very interesting. See, heparin was secreted by basophils. Many of you don't know this fact. Actually, for this purpose, I started this code. Heparin was secreted by basophils. And keep in mind, basophils are the least populated cells in the body. And those secretions are sufficient. That is, that levels of heparin is sufficient to keep core blood in equal state. That's why I discussed. 20 liters need only 4 drops of heparin. Now understood, right?
Yes, sir.
Heparin is very strong and basophils are very, very powerful actually, even though they are 0 to 1%. I want to tell one more thing, my personal story. In my BSc MLT second year, I studied in a government college. We have an actual practicals. Actual means actual. So practicals are connected with theory exam. If you fail in practical, you are detained in theory exam. That's it. Keep in mind. Understood, right? First practicals will be conducted. If you fail in practicals, you are not eligible for going for exam. Theory exam hall. Yeah, they will release examination dates after conduction of releasing of practical results. Very tough. What happened? My classmate, okay, my own friend, I felt very sorry about him. He kept a DLC, he made a staining, he got a DLC, okay. We got 4 practicals from shuffling and he got DLC and he made a smear and he's near a microscope. And the external came and he was very confidently saying he's looking at basophil and he wrote basophil count 20. Okay, and external asked once again, cross check, what is that, sir? He said basophil. He asked 4 times. And you know what happened? After the exam, we came to know that he was retained in practical and theory. Doctor was literally, he failed that my classmate. Doctors are very poor. You know, because our sample is our own classmate sample, and how this will be seen only in cancer patients. And now this technician will be in outside world and he will do such erroneous reports. So he failed it. Yeah, and there is one more incident. Comparative method, you know, this what is it? Fibrin thread. He didn't show fibrin thread to the external and he failed it. Yeah, he didn't show fibrin thread. So doctors are very cruel. Keep in mind, I came from that background, so you need to be cautious. Yeah, warning to you. Anyway, this is DLC. Next, PCV. What is the purpose of PCV? What is the full form of PCV? Yes, Faisal. What is PCV means? What is the significance of PCV? Why we need to study PCV? Yes, Faisal. What? That everyone knows. Why we are doing this test, Faisal? If I take your sample, why I did Attuluri, any more justification, more strong answer, characteristic of purpose of PCV. PCV will check the packed cells ratio with the volume of plasma. Okay. For example, imagine this room can accommodate 50 students. That is the normal condition. Okay. And room space is around 100 square foot. Okay. 100 square foot room has 50 students is the normal criteria. Now let us see. 20 students are there in a room. That means now this is a deficient room. Got it? 20 students in 100 square foot. Now the space is more and cells are less. This is an anemic condition. Okay? Now I will tell you another interesting thing. Along with 20 students, I have shrunken this room. I kept a wall up to here. In proportion to 20 students, then what will be the overall capacity of the room? Again, room capacity is normal. For 20 students, if I shrink the room size, it will become a normal capacity. It became a full capacity comparing to the room volume. Understood? If there are 20 students, I will shrink this room walls. I will make this room small. Now it became normal. That is the purpose of PCV actually. Sometimes patient to patient, the ratio to RBC to plasma will vary. So if the plasma concentration is less and RBC, packed RBC, ratio of RBC is tallying with the plasma, then that will be a non-anemic condition. For example, babies, just born babies. They are very less like, so if you do normal adult PCV, you will feel they have anemic condition. But compared to their RBC, their PCV will be normal. So patient actual anemic status can be determined by having a PCV value. It's giving the patient's plasma ratio to RBC ratio. Got it? So yeah, that is the idea of PCV. Then what is the ESR? What is the purpose of ESR? Yes. To check ESR. Infection. Okay, you are right. Why we are bothering about infection in hematology? This should be studied in microbiology, right? Yeah. How infection ESR is connected? Note down all these points. Okay, very important. How ESR is connected with infections or hematology? What is the significance of ESR? Yes. To check inflammation. Who said it? Your name is? Melissa, yeah. Melissa and Melissa are not confused. Okay, Melissa. Yes. How inflammation and ESR connected? Any idea? First of all, I appreciate Melissa. Then yes, tell me. Yes, Jarial Manpreet, right? You are Manpreet, right? Yes, Manpreet. Yes, Jagdeep. Any idea? But you studied ESR, right? Okay, I will tell you. Listen very carefully. Very interesting. ESR is very interesting lab test actually. Imagine there are two types of glass rods. There are two vertical glass rods. One glass rod has water and another glass rod has Fevicol. Okay? I hope when I said Fevicol you understood the texture of the liquid, right? Now, I draw two stones at same time in both the cylinders. I drop two stones, okay? Two stones like this at same time. How much time it will take for this stone to reach here? 0.1 second. Within 1 second it will reach here, right? And what about this stone? It might take 3 seconds to reach bottom. That travel is called as it will pack at the bottom. This is called as sedimentation. Traveling is called as sedimentation rate. How much rocks are sedimented, right? So now you understood the concept of sedimentation, right? Here instead of instead of stone, we have a red blood cell. How much time it is taking for an RBC to sediment at the bottom of a glass pot is called as erythrocyte sedimentation rate. Now, you already know the logic here. Fevicol. Here the sedimentation rate is very less compared to normal. Got it? Now, normally our blood has a normal sedimentation rate. Sometimes whenever there is an infection, body will create many antibodies to fight against infection. Body will create many antibodies to fight against an infection. Now, these antibodies will increase the viscosity of the blood. Antibodies will increase the viscosity of the blood. How to determine the viscosity of the blood? By performing ESR. When we perform ESR, the rate of sedimentation will reduce. There will be less sedimentation. So, decreased ESR indicates ongoing inflammation in the body or more antibodies in the body. Antibodies generates during an inflammation, and that is how an inflammation is connected with ESR, with an infection. And this is very important test for tuberculosis. For TB patient, ESR plays a vital role. Then you might ask a question. So directly we can do a TB test, right? Why we are doing ESR for TB patient? The golden rule in any lab test is first of all we need to go with the easiest, cheapest, efficient lab test. Is the first priority, not with the costly tests. So ESR will cost around 50 rupees. That's it. Just collect a blood, keep in a vertical tube, wait for 1 hour, you will get the results. It's cheapy, efficient, and easy to perform. Okay. If ESR came low, then we will go for the further diagnosis. That is for differential diagnosis. So now you know what is ESR also. These are the tests we will do in basic hematology. PWBC, DRBC, BLC, HD, PCV, ESR, and there is something called indices that I will discuss later. Coming to transfusion medicine. Here we are doing one important blood test, SS. What is that? Very good. ABO grouping. Any more test? Do you know what is cross matching? So we are doing something called cross matching that I will discuss later. So can you tell me the concept of ABO grouping? Now that is another big goal. Okay, I will discuss ABO grouping later. You just write the examples, ABO grouping and cross matching. Okay. Cross matching was done by a test called, any idea? What test is called as cross matching test? Yes. Name of the cross matching test? Coombs test. How many of you came by DMLT background? How many of you have DMLT degree? None of you. Okay. Yes, Pradeep, do you know DMLT? Have you done DMLT? You're on safe side. Okay. What are bleeding disorder tests? What tests we will do in bleeding disorders? Yes? Bleeding time? Clotting time? Then? There are other tests you might not know. They include prothrombin type, thrombin type, activator partial thromboplastin type, and the TGB thrombin generation test, and the APPT. Write down these test names. Prothrombin type, thrombin type, activator partial thromboplastin. Write down these 20. Activator partial thromboplastin type, and the thrombin generation test. What is similar, right? Combine generation test. This is Jagdeep and his name is Vidichandra, right?